Hello, welcome to the Mark Janard Show, the cybersecurity show. So there is an exploit that releases arbitrary code as soon as you click the solution, the application, what have you, and your computer system is screwed as a result of that. So in this video, I'm going to give you an overview of this exploit, how it works, and 5 other ways to hide source code as malware with the actual code snippets for each of them. I'm gonna give you actual malware code snippets that you can use, but this is a disclaimer, do not use this information for illegal or unethical use, okay? This is only for educational purposes, so do not use the actual malware code that you can use in the real world for any kind of nefarious use. So without further ado, let's get into it. We're going dark. So like I said, there's an exploit that releases arbitrary code as soon as you open it, right? Now, the steps for the exploit release of arbitrary code execution is identifying vulnerabilities, right? Attackers first need to identify suitable vulnerabilities in the target system. Common vulnerabilities include buffer overflows. These occur when data exceeds the allocated buffer size, allowing attackers to overwrite memory. Deserialization laws or flaws, right? Deserialization flaws, exploiting improper handling of serialized data that can lead to code execution. SQL injection, this allows attackers to manipulate SQL queries and execute arbitrary commands. Cross-site scripting, malicious scripts can be injected into web applications, leading to code execution in the user's browser. Craft malicious input. Once a vulnerability is identified, the attacker crafts input designed to exploit it. For example, in a buffer overflow scenario, the attacker may create an input that exceeds the buffer size and includes malicious payloads. Inject code, right? The crafted input is sent to the vulnerable application. This input may contain shellcode or other executable instructions that will be executed once the vulnerability is triggered. The attack leverages the fact that many systems do not differentiate between code and data, allowing malicious code to be disguised as legitimate input. And then there's the gain of control of execution flow, right? The attacker manipulates the instruction pointer, IP for short, or return address so that it points to the injected code instead of legitimate instructions. Techniques such as stack overflow or frame pointer overwrite are commonly used to achieve this control. The next one is, the next step in this thing, right, is execute payload, right? Upon successful manipulation, the injected code executes with the same privileges as the vulnerable application. This may allow for further actions such as privilege escalation, data exfiltration, or installation of persistent backdoors. And they got to cover their tracks, right? To avoid detection, attackers may erase logs or modify system files post-execution, right? This ensures that security teams cannot easily trace back the exploit or understand how the breach occurred. And escalated privileges, if necessary. If initial access does not provide sufficient privileges, attackers may attempt privilege escalation exploits to gain higher level access, like administrator or root within the system. And before we get into the 5 others, hit that subscribe button and the like button right now. Hit that subscribe button and the like button right now. So the first way you can hide malicious code in source code is the Unicode bidirectional BIDI control characters, homoglough characters, right? Control flow flattening, steganography, Unicode encoding manipulation, right? So let's talk about Unicode bidirectional BIDI control characters that can be misused to hide malicious code in source files, potentially compromising software security, right? This technique, known as Trojan source attack, exploits the way text is displayed versus how it's interpreted by compliers mechanism, right? BIDI characters like LRI, left to right isolate, and RLI, right to left isolate, are inserted into source code. These invisible characters alter the visual representation of the code without changing its logical structure. The compiler processes the code differently from how it appears to human reviewers. Now, what you would say as an example is, I got that code for you right now. Peter, please put that code snippet on the screen. By inserting BIDI control characters, an attacker could make the condition appear different visually while the compiler interprets it as intended. Security implications. This technique can be used to insert backdoors or vulnerabilities that are difficult to detect in code reviews, bypass security checks by hiding malicious logic, potentially compromise open source software integrity. The next technique we have is the homoglyph characters. In regards to character substitution, which is kind of like the first thing you got to do, you have to replace the standard ASCII Latin characters with visually similar Unicode characters from other scripts. In regards to code modification, you have to alter the logic of the code by changing string literals or function calls using homoglyphs. The function creation craft functions with names that appear identical to legitimate ones but use homoglyphs. Variable manipulation introduce homoglyphs in variable names to redirect program execution. And then next in this process is invisible insertion. Add invisible characters into lines of code. Script mixing is next. Combine characters from different scripts to camouflage malicious intent. Compiler interpretation is next. Exploit the fact that while visually similar, the compiler or interpreter will treat the homoglyphs differently. Code review evasion. Utilize the visual similarity to bypass human code review processes. So homoglyph attacks in malware code exploit visually similar characters to hide malicious intent. The next one we have is the control flow flattening, which is a technique used to obfuscate program flow and hide malicious code. The steps involved in this process are as follows. Follow this. Break down the function body into basic blocks. Place all blocks on the same nesting level, removing the original structure. Now create a single infinite loop containing a switch statement. Next, introduce a state variable to control program flow. Next, replace original control structures with state transition. Next, add a dispatcher block to direct control flow between blocks. Now, there are some additional obfuscation techniques, so to further enhance the obfuscation, you can use clones, which create semantically equivalent copies of basic blocks, dead clones, which add dummy copies of blocks that are never executed, OPA-Q, OPA-Q steps, which is obfuscate the switching variable to make it harder to determine the next case. Now, in regards to this one, Peter, please put the control flow flattening malware code snippet on the screen. Okay, the next one we have is steganography. Steganography. So select a carrier file, choose an image file like a JPEG, BMP, PNG that can hold the malicious payload without significant changes to file size or appearance. Create the malware payload, develop the malicious code or data to be concealed within the image. Encode the payload, embed the malicious code into the image by modifying the least significant bits of pixel values, ensuring minimal visual changes. Distribute the infected image, You're going to want to spread the graphically altered image through various means such as email, attachments, or web pages. Next, execute the hidden code. When the victim opens or processes the image, the concealed malware is extracted and executed. Now, the next one we have is the Unicode encoding manipulation. First, you gotta, character substitution, Replace the standard ASCII characters with visually similar Unicode characters. For example, using the, Peter, you can put that symbol on the screen instead of the O to bypass profanity filters. Right to left override, utilize the Unicode character U plus 22E to reverse the display order of the text. This can be used to disguise file extensions, making malicious executables appear as harmless files. And next is invisible characters in regards to that step, Insert Unicode characters that are not visible when rendered, allowing attackers to hide malicious instructions within seemingly innocent text. Code point obfuscation. Use Unicode code points to represent characters instead of their literal form. This makes the code difficult to read and can bypass string matching defenses. Then next is the diacritic tick stacking, combine multiple diacritical marks with base characters to create complex, hard to detect combinations. Next, surrogate pair manipulation, exploit the UTF-16 encoding to create characters using surrogate pairs, which can be used to obfuscate malicious code. Next, variation selectors, employ Unicode variation selectors to subtly, right, alter the appearance of characters without changing their semantic meaning. So that's what I have for you today. Hit that subscribe button, hit the like button if you were educated and entertained. See you in the next video.